Okay, last set of examples here for 6.1. So here I've just written out something that we said in the previous video, or maybe it was a couple videos ago, but when you're dealing with these inverse trig functions, it's not always the case that trig inverse of trig of u equals u. Okay, that doesn't always happen, and we saw some examples earlier that kind of demonstrated this fact. However, trig inverse of u is always equal to u, right? Every single time that's the case. The reason I'm writing that out now is because it comes in handy for this particular example. So here we're being asked to rewrite this expression as an algebraic expression, right? So right now it's a trigonometric expression. We want to rewrite it as an algebraic one. Right? So just in terms of algebra, so like squares and square roots and things like that. We want to basically get rid of all the trig functions involved. So let's see if we can do that. So I'm gonna do the same trick that I've been doing. I'm gonna say this thing right here is just an angle, right? So I'm gonna say let theta equal sine inverse of u. I don't usually write my u's with a little stem, but I think if I don't write them with a stem, it looks more like a V. So I'm trying to change the way that I write them. Anyway, so then if that's the case now, we're looking for cosine of 2 sine inverse u. That should just be cosine of 2 theta, right? Since the sine inverse of u is, we're just calling that theta. Well, turns out that we actually have three different double angle identities for cosine 2 theta. Since we're given information about sine and no information about cosine theta, I think we should use the one that only uses sine theta, right? So we can say, so the one that uses sine theta is, I think it's 1 minus 2 sine squared theta. Is that right? Yeah, 1 minus 2 sine squared theta. Now the question is, what is sine theta, right? In other words, this is like 1 minus 2 sine theta, right, squared. But what is sine theta in terms of u? Well, if theta was sine inverse of u, then that means that sine theta equals u, right? Just by definition of the inverse, right? So if theta is sine inverse of u, then u is sine theta. That sounds like funny grammar, but u is sine theta. So sine theta here we can just replace with u. So this is 1 minus 2 u, 1 minus 2 u squared. And that's it, right? That's our algebraic expression. So this thing, cosine of 2 times sine inverse of u, that's exactly equivalent to just 1 minus 2u squared, which is really nice. This demonstrates why I think it's important to go through the exercise of thinking through these kinds of things, even though a lot of times you can use your calculator, but your calculator wouldn't have been able to simplify it this way. Well, maybe. Some of your calculators maybe would. But anyway, this kind of stuff comes up in calculus all the time. In second semester calculus, when you're doing integration, you're going to do some trig substitutions. That's a big technique in integration. And in order to get your answer from its trigonometric form back to its algebraic form, you end up doing things like this a lot. Let me give you another example of that. So let's do sine of tangent inverse of u. Okay? Same sort of idea. pause the video, see if you can work it out on your own. I'm going to work it out now. I'm going to say let theta equal tangent inverse u. Then that means that tangent theta equals u, and that theta is between pi over 2, negative pi over 2, and positive pi over 2. Okay? I guess we don't actually know which quadrant we're in. That would depend entirely on whether u is a positive number or a negative number, right? So we can look at two separate cases, right? If theta is in quadrant 1, then we've got this scenario. So we've got opposite over adjacent. If theta is in quadrant 2, it would have to be the negative, or sorry, not quadrant 2, quadrant 4. If theta is in quadrant 4, it would have to be the negative angle in quadrant 4. But again, we would have this scenario, right? Theta is opposite over adjacent. And remember, u is already a negative number, so you don't have to call it negative u here. It already stands for a negative number in the case that we're in quadrant 4. So anyway, we can solve for the missing side. I think in both cases, we're going to say u squared plus 1 squared equals r squared. So u squared plus 1 equals r squared. So r is technically, right, we would say plus or minus square root u squared plus 1. But r always represents this distance. It always represents a positive number. So here I'm going to say this is the square root of u squared plus 1. You'd get exactly the same thing over here, right? Square root u squared plus 1. So let's finish the problem now. We're looking for sine of tangent inverse of u. In other words, sine theta, right? Because we call theta tangent inverse of u. Well, let's think about what sine theta would be. If we're in quadrant 1, sine theta would be opposite over hypotenuse, u over square root u squared plus 1. If we're in quadrant 4, sine theta would be opposite over hypotenuse, u over square root u squared plus 1. So regardless, it doesn't matter, right? Regardless of the quadrant that we're in, sine theta is going to be u over square root u squared plus 1. And there it is as an algebraic expression. I am not going to try to rationalize that. Well, not that it would be hard. Maybe I will. If you rationalize it, you just multiply by square root of u squared plus 1, right? So you just get u times the square root of u squared plus 1 over u squared plus 1. I'm not sure which answer the book will have. They're both fine. Okay. So that's that. Okay, that concludes our discussion of 6.5.